Yes, Pari.
Okay, so you're able to see my screen. Okay, that's good. Okay, so first we will start with what is RDD, and we will focus on RDD, some of the RDD transformation and RDD actions, and we will then once we comfortable with a few of the RDD transformation and actions, then we will go through the a little bit of architecture. Okay, so I will start with this. And I think Surendra is having this environment on his machine. And what about Profella? You did you try to install, or you're planning to do today? Or hello, Profella, you have an installation like you installed Spark on your local machine or VM. Installation is done. Spark installation. You are on mute, Profella. Okay, maybe is away. Okay, no problem. Yeah. So please install Spark so that you can practice. So we'll start with the what is RDD. RDD is nothing but a resilient distributed data set. Okay, is a basic abstraction in Spark. Okay, so you can think of as a if you want to say in very layman term, it is a again just data type in Spark. Okay, you can just uh, basic data type in Spark. So or you can think of as a collection object. So RDD is actually immutable, and it is partitioned collection of elements that can be operated on a parallel. So when we say collection, so it's going to have multiple elements, right? Collection of elements that can be operated in parallel. Okay, so you cannot actually modify RDD. That's why it is immutable. So you can perform some operation on RDD. Those are called transformation and actions. So say example, you have RDD, okay, and they're saying it is immutable. So how do you process the data inside RDD? So basically when you apply a transformation, you get a new RDD. So you will not actually modify the existing RDD. Instead, you apply a function on top of the RDD, and it will be applied on the data, and you get a new RDD. Okay, basically you are not trying to modify the existing data. Instead, you take the data and modify the data and derive a new RDD. Okay, that's what RDD does. So whenever the uh, transformation is applied on a particular RDD, you will get a new RDD, which will have the basically output of what transformation functions you applied on it. In this case, say example, initially this SC nothing but you can think of as a Spark context. So Spark dot this statement will be now Spark dot Spark context dot text file. It can you can read a text file. So whatever the content in a text file, that will become RDD. So this text file will basically a RDD. Okay. So you can apply a transformation. So example, this is RDD. Text file is RDD. When you apply a filter transformation, okay, so you are applying some uh, function here, right? So this function will return set of values. That is actually another RDD. Okay, so whenever a transformation applied on RDD, you get a new RDD. So that is one type of operation, right? The another type of operation is action. So action, when you apply action, you get a result. Okay, so so example, if I apply action and the lines with the Spark, so what is action? I can apply action called count. Okay, so I will get a number of elements in this RDD. So lines with Spark RDD. Similarly, I can apply another action called first. It is going to give me the first element in the RDD. So So whenever action is applied, you get the value. Value is nothing but the result or the content in the RDD, the output in the RDD, whatever you call it. Okay, so that's what you need to understand RDD. Okay, so RDD is nothing but a distributed collection. So you can think a list is basically when we. Okay, so we'll start with the example, few of the examples. So when I create a list with numbers, right? So this becomes a numbers list. So this list is basically will work on only on this machine. Means this list can be processed only on this machine. But when you create a RDD out of this list, that RDD can be operated on the multiple machines. Okay, so you can make use of the parallel processing or distributed processing. Okay, so we'll start with the few of the examples. So I will launch a PySpark session. So you can stop me whenever you have questions. So when you type PySpark, so it is launching a PySpark session. Okay, so I will just go and create this list. So this is basically a simple Python list, right? So if you want to convert this list into RDD, what we do, we just have to say Spark session dot Spark session object. Excuse me. Spark session object dot Spark context, which will have another method called parallelize, and you can pass the list, the Python list. Then it will create a RDD. Okay, so RDD of numbers. And there is one more parameter. Okay, so parallelize has one more parameter, which will create a number of partitions. Okay, so so basically partitions, I think we discussed in the Hive, right? So basically it does actually I'm very sorry. So when you say parallelize and pass the Python function and another argument called number of partition, basically it will slice your data. So now you have a uh, um, you have 5 elements here. So when you create a parallelize without providing the second argument, so it might create a RDD with one partition, right? So all the elements in the one partition. So if you want to actually slice your data into multiple partitions, so that how many partitions you have, that many number of parallel tasks you can run. Okay, so that's the reason you need to have some optimized number of partitions to increase the parallelism. Okay, so example, I will try to create without the second argument. So we have a numbers RDD, right? So now if I try to get the number of partitions, so there is a function called RDD is get num partitions. So it gives by default 2. So I did not provide the second argument how many number of partition it has to create. So it is actually created automatically 2 partitions. Okay. So we'll understand how to. We'll also see like which partition has which elements and all. We'll just see. Okay. So later I'll tell you there is a function to do that. And so That's one way. I will try to create it into 3 partitions. Now it has become 3. Is the text is visible, or you want me to increase the font?
It's visible.
Okay. Okay, this is one thing. So okay, now we created our RDDs, right? So this RDD will have a set of functions. Those functions are broadly categorized into transformation functions and action functions. So you can just check using the DER method. You can know the number of functions available in a RDD. So these many number of functions available in RDD. So if you want to know the segregation, so you can go to the uh, Spark programming guide. So open this link. We go to RDD operations. So you will have a list. So what are the which are the transformation functions? So there is a function called map. There is a function called filter, flat map, map partition. There are n number of transformation functions. And if you come down, there is the action functions: collect, count, first, take, reduce, and there are functions which will write your RDD data into files. So those functions also called action function. Save as text file, save as sequence file, and you have a for each function to iterate your RDD and see the result. Okay, so you can just go through this link. It will have just to want to know which are the functions belongs to actions and transformation. Now coming back to this, now we created a RDD, right? So we will start with the very simple transformation called map. So if you look at this documentation, so map is a transformation. So each transformation takes input as a function. So basically, it takes a function and applied on the elements in the RDD. Okay, so once this has been called, it returns a new distributed data set, which is nothing but RDD, formed by passing each element of the source through the function func. Okay, so that's what I said. So basically, it will take this function, whichever function you are giving, it will go and apply. Uh, it will go and apply on the data, or each element will be sent to the function, and it will give the result. Okay, finally. So if you take that example, we take number RDD. I take number RDD, and if I apply a map transformation, I need to pass a function, right? This function, I'm writing a lambda function. What it is going to do, it is going to so lambda function will be able to iterate your elements, right? So map transformation will be this function will be given to the map transformation. You can actually iterate all the elements and take lambda of n, means taking a first element and actually finding the square of n. Okay, so it, okay, so you can apply is okay. So this is going to return the name again. Sorry, square. Yeah, it is going to return the square of the each element in the RDD. So 1 to 5 we add. So apply this square function. Okay, so you take each element and apply a square and find out the this one. So now if I try to collect this, so I said you if you want to see the output, so see we have the RDD, right, which is created from the Python list, and we know this 1 2 3 4 5 element is there. So now new RDD has come when we applied the map transformation. So if you want to see the elements in this RDD, so what happens is we have to apply a action function. Until you apply action functions, you cannot see the result. So basically it is all the elements is squared and you see the result here. Okay, so we RDD is nothing but a distributed collection, right? So this is a simple Python list and we collected as RDD. Okay, and we applied a transformation. Okay, so we created a RDD using a parallelize function, and we applied the map transformation and we got the new RDD. Okay, so I told you unless you apply action function, you will not see the result. Okay, so one more thing to note is whenever you apply transformation, right? So you get a new RDD. Okay, but actually the it will actually whatever operation you perform, it will capture what it has to perform, but it will not execute immediately, which means all the RDD transformations are lazy evaluation. So it will just keep whatever you pass. So okay, so I need to apply a map transformation with the function which I'm applying on this number RDD, and it will give me the square RDD. So it will give you the object, but if you internally it will not have the this output on this RDD because it is just a lazy evaluation. It is just capturing all the metadata. Okay, so whenever you perform an action operation or action function on top of RDD, then only the execution will start. So then it'll go and try to get the data from square RDD. Then the square RDD will be have to be derived from the uh, number RDD by applying the map transformation. That will happen. Then so it will go on to see how the uh, this number RDD. Okay, so number RDD is okay, so I think parallelize is not a uh, transformation, I guess. Okay, so it will come here. So basically what I'm trying to say is transformations are lazy evaluation. Okay, and uh, actions will perform the action will initiate the actual execution of your uh, RDDs. Okay. Okay, so and so how do you? So basically, I told you transformations are lazy evaluation, right? So if you apply multiple transformation, how it is captured, right? So say example today, like I collected, I am trying to collect from the number square RDD. Okay, but before that it applied only one transformation, which is map transform. Say example, if you have before doing the collect, you applied a multiple transformation like map, filter, and a flat map. There are other multiple transformation applied. So it will keep tracking of how each RDD is derived from. So it will have the tracking. So that tracking is nothing but lineage. So the RDD will have the lineage. It means They take a particular RDD, what is its parent, where it is derived from. So those information it will have. So that is nothing but a lineage. Okay, so RDDs will capture the lineage. So where the RDD is basically derived from, and with what function it is derived from. All the things. Okay. So I want to show you this uh, image actually. So this gives more information about RDD. Okay. So if you look at the RDD, RDD is basically will consist of a set of partitions. Okay. Uh, the partitions will be, if you're reading a file from HDFS. Okay, so then the number of partition will be very equivalent to the number of blocks the file which are reading from HDFS. Okay, for the, and it will have a list of dependencies. Okay, so basically from what is the parent RDD for this RDD, and so it will have anyway the function to compute the partition from its parent, and it will have a preferred location of each partitions, where the partitions are located, and it will have the so basically it will have the uh, partitioner. What is a partitioner? What is a partitioner technique it has having? Okay, so there is hash partition and range partition. By default, I think hash partition is used. Okay, so internally, okay, so for uh, it will be very kind of these words are very jargon words, but slowly you'll get into these things. Okay, so RDD will have all the things. So how the lineage is captured using the dependencies. Okay, so if you internally look, these are the information the RDD will contain. For us, if you look at here, for us it just if you look at this, I have a simple list. I converted that list into RDD using a parallel. So that's what as a programmer we see. But internally, it captures all this information. Whatever you see here, internet is captures all the information. Okay, so that is the one thing I want to convey. Now, I think map transformation is very simple transformation. So let's go to the next transformation. Okay, so here only, okay, this is numbers we saw. So, say example, I have a list with the string elements. Okay, so let me create a RDD out of string. So I just created a string RDD. So if you just type of, so it is RDD, and if you where it will say, okay, fine. So, and there is one more method is there. Okay, so RDD dot to, I think it's a, okay. It's also giving this information. Basically, the to debug string will give you the where it is actually come from. Okay, so we actually it's a collection dot. This is not giving much information, but actually, if you did multiple transformations, and if you try to see the debug string for the final transformation, you will see that the lineage structure. I will show you the whenever we go there. So or maybe we'll apply some transformation and then we'll see. Okay, maybe we'll see on this square RDD. fine. Okay, so now we created a string already. Okay, so we'll try to create this function. And okay, so we will say map of these functions. And I'll say collect. So okay, so so I created a sorry, I created a simple function to just change the case of the string which is passed. So basically, we are converting it to uppercase. So in the RDD dot map transformation, you can pass a function. So if you pass this particular function, so that function is applied on the each element. It gives the result as a uppercase. So we actually have the initially I think I did not print it. Basically, okay. So even if I print the string already, okay, we'll try to print the string already. So the string already has all the element first letter as uppercase, remaining a smaller case. So when we did a map transformation and pass this function, it applied on all the elements and given us the uppercase. Okay, this is like when you how do you apply your functions or on a string RDDs. Okay, and this is basically both the string RDD and number RDD we created from the Python object. So what happens or how we can actually get create a RDD from reading a from file. Okay, that's we will see next.
Pari, I have one question.
Yeah.
So without giving the partition, can we assign the function directly on PyStr list?
PyStr. Okay. So on this.
Yes.
Oh, what are you saying?
So we are applying the function called upper for the strRDD, right?
Yeah, yeah.
So without giving the partition, like can we apply the function straight away on that particular list?
Okay,
Can
so
we do that,
basically,
or
see,
sorry?
this is a Python object, right?
Okay.
So you can apply. So basically, okay. So if I just normal, I think in map Python map also. This example, I can create. In this right, yes. You mean to say like this?
Oh, okay. Yeah.
So this
So
is, yeah, this is basically just we are doing a Python operation. Means we are applying this function on a Python object. Okay. So
got it.
here, yeah. So this is this will happen. This execution will happen on only on this machine. Okay. So, but when you convert this Python str list into RDD, So this will have see anyway. I'm just running on this machine just for learning purpose. But when you run this on cluster, what happens is so say example when you apply a map transformations. Okay, so we apply map transformation and pass this function. So what happens is, so since this is created with the two partition, so two partitions will run in parallel on a two different machines. So that is the advantage this RDD gives. But if I run this line, it'll the operation will be performed on only one machines.
Okay, understood.
Yeah.
Thank you.
No problem. Okay, so what I was okay, so if you want to read a file and create a RDD, okay, so I have one file here. So there is a tech.txt file. So we have some 5 elements. So I want to read this file and create RDD, okay, rather than creating from the Python object. So what we need to do basically, we have a function called text file under the Spark transformation. So Spark transformation we used to parallelize. Now we will use the function called text file, which will take a path of your text file and it will give, I'm sorry, and it will give you a RDD. Then once you have RDD, then it's same as what you perform other operations, right? So let me run this code. Why I am using file colon triple colon? Basically, if I just give the normal path, it'll consider that path as a SDFS path. Okay, so since I'm going to read it from my local Linux machine, so this I put it in a my Linux machine. So this file is in my Linux path. So that's why I'm using a file triple colon. If your file is in HDFS, then you don't need to provide this file colon this triple slash. Just you have to give one slash. That's enough. I think I have not started any Hadoop daemon, so HDFS and all. We'll just trying with the local. We will do reading from HDFS also. Okay, so that is a path of my file. Then I'm going to create tech RDD by reading that file. Okay, so this should have given me the RDD. See, it is taken from that. It is map partition RDD. It says. Just let's do the collect and see what content it has. Same list of strings which is there in that particular file. Now we can just apply map transformation. Let me apply the lower case on each element and we'll try to see this. So all the elements became lowercase characters. Okay, so we saw how do you create a number RDD out of your list which has number elements, and also we saw how to create a string RDD from your Python list which contains string elements, and also we saw how to create RDD from a file by reading a file, and we applied the map transformation. So in simpler terms, map RDD is used to iterate your, one of the way to iterate your elements in RDD is a map. So but it's basically a transformations. So you can apply the function, you have to apply the function to the you have to pass the function to the map transformation. Okay, so this is one transformation. Okay, so we have only 1 minute left. Please join with the same link and we'll start with the other transformation. Thank you.